Okay, so in this problem it says that a street light is at the top of a 16-foot tall pole. A woman, 6 foot tall, walks away from the pole with a speed of 4 feet per second. Let's start circling these. 6 foot, 4 feet per second along a straight path. How fast is the tip of her shadow moving when she is 35 feet from the base of the pole? Okay, so let's draw a little picture here to see what this looks like. We have a pole. Let's draw a pole right here. And a little light. And this is 16 feet. Now this is constant, so this is not going to change. So we can put the 16 there. And then we have the woman. And let's say she has red hair. And she's smiling. Now you can't see the smile, but she's smiling right there. And let's say she has red shoes. Red shoes and red hair. Okay. And so we're going to draw a little line here. Now notice what's going to happen is that this light is going to project along here, and it's going to project a shadow from her to this point right here. Okay, so notice that what we're looking for, let's see, let's try to label a little bit more. She is 6 feet tall, so so from here to here, this is 6 feet. Ooh, let's give her some green gloves. How about that? Maybe it's a little cold, so she has some green gloves. Okay. Alright, so she's 6 feet tall, the pole is 16 feet, and this is our shadow. Now the question is, how fast is the tip of her shadow moving when she is 35 feet from the base of the pole? Okay, so what we want to do, I guess, is we want to finish labeling. Now why don't we call, since what we're looking for is how fast the tip of the shadow is moving, so we're basically looking for how fast this distance is changing. Now why don't we label this, how about x? So we'll label this distance x, and let's label the distance from the pole to the woman, let's label that y. And so if we do that, then that means that this little distance right here from the woman to the tip of the shadow, that's going to be x minus y. Okay. Alright, so now that I put a variable, a symbol for all these distances, let's label our information. Here we have that the woman is walking 4 feet per second. So the distance from her to the pole is y. So this 4 represents, let me put it down here, dy over dt. So then that means that we have dy over dt is equal to 4. And it's positive because it's increasing. The distance is increasing. Okay. Now, this question, the question how fast is the tip of her shadow moving, this is what we're looking for. This is going to be dx over dt. And the 16 feet and the 6 feet, well, these are constants, so we don't really need to label it anything necessarily, although you could just assign these a letter. But we have the picture, so that can take place of that. Okay, so we have the labeling done. So this is the labeling and drawing a picture. Now the second part is, remember, we need to find a formula that relates all of our information. And, well, you look at this, and this doesn't look very formula friendly. I mean, we have the Pythagorean theorem, but that doesn't really help us very much. But notice that if you look at the outside triangle and this inside triangle, you'll notice that these are similar triangles. So if you look at these as similar triangles, well, then you can write a proportion. You can say that, for example, x over x minus y is equal to 16 over 6. Okay. Now, since the one that we're looking for is dx over dt, well, it would be smart to solve for x here. So why don't we get rid of all the fractions? We can multiply both sides by 6 and multiply both sides by x minus y. And so we would get 6x equals 16x minus 16y. And if we solve for x, we bring the 16x over to the left. We would get negative 10x equals negative 16y. And so that means that x is equal to negative 16y over negative 10y. Or in other words, x is equal to 8y over 5. Okay. Well, if I know that x is 8y over 5, well, that means when I get the derivative of both sides with respect to time, what I get is on the left, well, I'm going to have dx over dt, and on the right I'm going to have 8 over 5 as a constant, so I can leave it out, and the derivative of y with respect to time, well, that's just derivative of y with respect to time. But notice that I know what this is. I had it before. It's right here. So the interesting part about this problem is that it's deceptively easy. Because you see, once you have everything labeled, you have the similar triangles relationship, and you notice that, well, the derivative of x with respect to time, which is what we're looking for, is just 32 over 5 feet per second. And so if you look over here, this guy, this 35 feet, is actually not relevant for the problem at all. It has nothing to do with the rate at which the shadow is moving. The only part that matters is how fast she is actually moving. It doesn't really matter how far she actually is from the pole, and I think that's pretty interesting. And so that's it. It's the answer.